Here's an example where you're asked to find the missing parts of an oblique triangle. And just as a reminder, an oblique triangle is a triangle that does not contain a right angle. All right, so we've been given a little bit of information about a triangle ABC in this example. The first thing you should do is draw a picture. So when you draw it, the only real important thing is make sure that you don't draw a right triangle, just to remind yourself that you're not looking at a right triangle here. Label the angles A, B, and C. The convention is to use capital letters for the angles. And then lowercase for the sides, A, B, and C. You label each side opposite of the corresponding angle, the way I have here. Now we're given some information. I'll write the given information in red here. So we're given that angle B right here is 63 degrees, and angle C over here is 52 degrees. And side A right here is 16.7 feet. So the red information is what's given. Now the first thing, if you're given two of the angles, then the easiest thing to do from that is to find the third angle, just because the sum of the angles in a triangle is always 180 degrees. So if we want to find angle A, we just take 180 degrees in the triangle minus the two known angles, so 63 degrees and 52 degrees. And that gives you 65 degrees for angle A. And so that's 65 degrees. I mean, it's not really given information, but we didn't have to round or anything, and we're pretty confident in our ability to enter that into the calculator, that that's going to be exactly correct. So, I mean, I tend to treat a value like that as if it's a given value. You're not worried about round-off error or anything like that. So now the only missing parts of the triangle that we need to find are side B and side C. Well, I'll just start with side B. I'll go alphabetically here. Since this is not a right triangle, we can't use the old like sine is opposite over hypotenuse and that stuff, because there is no hypotenuse. Hypotenuse is the side opposite of the right angle, and there's no right angle here. So we really have to use law of sines. When you set up law of sines, it's best to put whatever you're trying to solve for, put that in the numerator. So if I put side B in the numerator, that would go over sine of angle B. And then, now I need when you use law of sines, you need one pair, an angle and a side where you have all of the information. Like here we know angle A, we know the measure of angle A, and we know the length of side A. So there's our complete pair. That's what we want to use. So side A is 16.7 feet over sine of angle A is 65 degrees. And then I guess I should enter here B, angle B, we know this was given as 63 degrees. Okay, so to find side B, we're just going to multiply by sine of 63 on both sides. Multiply by sine of 63 degrees here, multiply by, oops, sorry, this is going to look messy as usual, sine of 63 degrees here, so that these cancel, and now we just have to multiply out this. So B is 16.7 feet times sine of 63 degrees over sine of 65 degrees. Now, one thing about calculators here, especially if you have a TI, I think 83s and 84s, you have to be real careful with this. Well, first thing, these are degrees, so make sure you're in degree mode. Also, if you have a TI 83 or a TI 84, when you press sine, it opens up a parentheses on its own without you asking for it. So you press sine and it automatically opens the parentheses. Watch out for that on your calculator. If it does that, then it's really important that you close the parentheses after the 63 degrees. And same thing in the denominator. When you press sine, it's going to open up that parentheses, so make sure that you close it. You should get about 16.418 something or other when you compute this. And so we would round that to maybe 16.4 feet, since we were given, you know, the 10th place, 3 significant digits here. And so that's the length of side B, turns out, 16.4 feet. You could do the same thing to solve for side C. You're going to put C over sine of C, which is 52 degrees, equals, and then here, yeah, the 16.4 is rounded, so it's best to go with the setup we have right here. Use the 16.7 side A over sine of angle A. Just the only difference when you find side C is that you'll have C here over sine of C. And you should find, when you do that, I'm not going to keep it in this video, so I'm going to keep it short, but C should be 14.5 feet, and you can check that in the PowerPoint. I've typed all the arithmetic to find that.